Hello guys and welcome to Freebird's Crew. So in this video I will tell you about the mathematics and working behind the decision tree. So decision tree solves the problem of classification and regression as well. So let's start with the classification and learn about how decision tree formulas that I already explained in the previous video, that is entropy, information gain and Gini impurity, helps in splitting the decision tree for classification and regression. Let's start with the classification first. So as you see on my screen, I have this small data set over here which predicts the result of the student based on the hours he studied and based on the previous score as well. Okay, so if you want to predict the result column, okay, so first the classification in decision tree, it calculates the initial entropy of the result column. So initial entropy of the result column is a pass or fail. So we have 6 pass rows and 4 fail rows, and we have total rows of 10. So to calculate the initial entropy, we use the entropy formula, and here is the entropy formula. With the help of this entropy formula, we calculate the initial entropy. So initial entropy is 0.97. Okay, and then we have these two columns, hours studied and previous score. So based on these two independent columns, we need to split which columns gives us the more information gain. So which column gives us the more information gain, we use only that column to split the decision tree and predict our result column. Okay, so I just divide this thing into the two parts. The first, we use the hour studied column to calculate the information gain, and then we use the previous score column to calculate the information gain. Okay, so let's take the hour studied here. So I just divide into two parts: the student who studied less than or equal to 2 hours, and the student who studied greater than 2 hours. Okay, so I divide into two groups. Okay, I take the first group, and in that first group I calculated the number of passes and then number of fails and then the total student coming under this group, and then I calculated the entropy of this group. Okay, and then similarly I calculated the group 2 pass or fail and total, and then calculated the entropy by using the same formula as the shown in the right side. Okay, and then I calculated the information gain. Information gain I calculated by using this formula as you see on the screen, and information gain that I got is 0.099. Okay, now let's calculate the information gain of the previous score column. So in the previous score column, I just take two groups. The group 1 has the score less than is equal to 60, and the group 2 has a score greater than 60. Okay, so when I calculate the entropy of these two groups by the same method as I calculated in the hour studied group 1, group 2, I calculated the information gain here, and the information gain that I got in the previous score is 0.22. So between these two, which information gain is higher? So information gain is higher in the previous score column. So I use the previous score column to split my decision tree because it has high information gain. Okay, and in that way, if you have multiple columns as well, this process will be keep on following. Okay, until you get the pure split. Okay, the pure split, as I explained in this, we have this decision tree, and you see the red dots and red dots on the one side and blue dots on the right side. This is called the pure split. Okay, when you achieve this pure split, you can say that yeah, my decision tree splitting is done. Okay, so now let's move to the example of regression decision tree. Okay, so in regression decision tree, we have the mean square or the reduction in the variance that we keep in the focus. Okay, so we have this data set of the house price. Okay, this is the house square foot area, this is the number of bedrooms it has, and this is the price. Okay, and with the help of that, first I calculate about the initial variance of the target variable, and then we calculate the mean. Okay, the mean price is the 4 million. Okay, and the variance is equal to the 1.9. Okay, so we have the variance now, we have the mean price now. Now we calculate the reduction in variance if we choose to split our decision tree by using the square root column. And if we use the square root column, we check that. Similarly, in the regression problem, we use the same method. We first take the column and divide into the two groups, the square foot which is less than 1600, which is greater than 1500. And when we take that, we go to the mean price and variance, mean price and variance. Okay, and then we calculate the reduction in the variance. So reduction in the variance is actually done by this formula. Okay, so when you put values in this formula, you get how much reduction is done in the variance. Okay, and then you check for the group 2, and for the group 2 we just and then you check for the bedroom column, and the bedroom column we make the same groups, group 1 and group 2. Group 1 has the bedrooms less than 4 and group 2 has the bedrooms greater than 3, and then we calculate the mean price and variance, and then we check the reduction in the variance. Okay, so reduction in the variance in the square foot column is 0.3, but in the bedroom column we got the reduction is equal to 0. Okay, so this actually shows the maximum reduction is done by the square root column. Okay, so we use the square root column to split the decision tree. Okay, similarly, if it has the more columns, we can use the same technique again and again to choose the best split, which reduce the variance more. Okay, so in that way, classification and regression decision tree split internally. Okay, it is based on this entropy, information gain, variance reduction and gain impurity formulas only. Okay, so thank you so much. If you have any question, you can put it down in the comment section, and in our next video I will tell you about a project by using the decision trees. Okay, thank you guys.